This video completes what we started in video number 24, a complete warp-based HTTP server. We'll add multiple routes, authentication, and other stuff. Let's see. We start by having multiple routes. This program is essentially unchanged from before, except that we now have a get and a post handler. Let's look at how this is all put together. Here I declare the API for the get handler. I use the warp path macro. I say it should be get, and then I use an asynchronous handler function called getHandler. Likewise, I define the post. For this, I ask for the body to be transmitted to my post handler. And then I put the two together by saying my complete API is API get.or the API post. This is a good opportunity to explain that all these things we put here together are essentially filters. So the type of this here is crazy, but it should not bother us here. What we produce is filters. So every one of these tries to accept a request coming in if it matches, and if not, it rejects it. For example, if somebody uses a different path than this one here, then this path macro will reject this road. Or if we use this path here, but we use a different method, then also this will be rejected. Now, the fact that we put together multiple filters here with or, in this case 2, means that the first one is tried first. If it succeeds, then fine. The request is handled by that one. Or if it rejects, then it's handed to the next one, and the next one can try its luck. If all fall through, the system will produce some error. So this is unchanged from before. We have get and put. Let me quickly run this. It's just building. Now it runs, and I use a different console to both try API person max a get request, which works, and I do a post request. I give a body, say max, and age is say 54. It says method not allowed. What's going on here? Ah, yes, I have here the long path that is not fitting to the short path for the post. Therefore, it says, therefore both APIs have rejected it. But if I use the short one, it has worked. So let me explain this effect in a bit more detail. The first route has rejected because it was a post, although the path was fitting. And the second route has rejected because the path was different. And I end up with method not possible because this one, the first one, has rejected the error. We get to error handling later. So multiple routes are basically done with this OR method here. That's the lesson we have learned now. Now let's add a bit of error handling. If you look at the post handler, then it gets a JSON body, and we use the asserted JSON from slice method to deserialize this. Now, for now, we didn't do error handling. We just did unwrap, but now we want to handle the error. Now, what we get back from asserted JSON here is either an OK, in which case we can give the object back as before, or it can be an error type, because the parser gives a parse error here. Now, in this case, we want to give an error response. For this, I have built an error body here. That's a new object I introduced up here. It has an error code and an error message, and it also has automatic serialization and deserialization. So I just do whatever I wanted to do. In this case, I give a status code bad request, and I hand out the JSON for the error message. Let's see how this works. If I run this program, and now I do a curl, and maybe I get the JSON not quite right. Look at this here. I get an error message, error code 1, and error message comes from the JSON parser, missing field name, name X. Well, name X was given, but name wasn't given, so therefore it was missing this. And I get a huge amount of different nice error messages. For example, if I would put a string here in the second thing, I get string expected in I32. Yeah, so due to the fact that we have here declared the object as a body and have automatic serialization deserialization, I can now very easily handle the error and give very nice error messages back. And I've done this by just in my handler either returning a good result or a bad result. It's as easy as that. We continue with error handling. The way to handle each error in each handler is okay if you have lots of different errors. Now I want to talk for larger projects that you can somehow unify the error handling. Let's look at what you can do if you want. First of all, I have changed the API here, my get route and the post route, and I've added a .recover at the end with a function called handle errors. The idea is as follows. Provided all my handlers or all my APIs here have rejected the request, then I fall through here. And with this recover method, I can direct what actually happens when all these routes have failed. Yeah. So let's look at the handle errors function. The handle errors function now gets a rejection, and that is essentially the object which the handler have given out for a when they rejected the route. It has to return a reply. The error case is not possible because the recover method must not return an error. It's just for the sake of uniformness that you have to have an error result here. That's why we use infallible here. So here we distinguish cases. One of the possibilities is that this error is a not found because all routes essentially just rejected. In this case, we give out an error body. So this we do now ourselves. We give our uniform error handler, we use code 404 and as message not found. The other possibility is that we use the find method here with this type here, because that's one of the built-in warp rejections that the method was not allowed. So if that happened, that's happened. If one path accepts it, but then the method is not configured. If we see that, then we hand out a method not allowed. And here I've done a custom error. Let's see how we organize this. If we return an error body object as rejection, then we give bad requests and just hand out the error body. Now let's look into our post route, how we can actually achieve this. Remember that in the previous version, we just gave out an OK here with our own reply. So the handler was actually accepting the route and the request and was handling it itself. Here, we use the rejection part of the response. That is, we produce a warp reject custom object and give in our own error object. And we have to give it with the error case here. Now, why are we allowed to do this? Why can we use the error body object as a rejection? Well, that is because up here, I've implemented the warp reject trait for this error body object. You don't have to implement any methods. You just have to mark this struct as a possibility to use in a rejection of warp. So by adding this one line, I've improved this struct such that I can hand it out in a rejection. And indeed, I just return a rejection here. That is, if somebody posts something, the route hits, the JSON is passed and it went wrong, then I return from this here with an error object with a rejection. And then the handle errors case can catch this and can here find the right thing and can hand out the error body. Let's see this in action. So let's just do a parsing error again. Indeed, I get error code 1, error message like this, and I think the status code will be bad request. Yes, 400 bad request. Obviously, if all goes well, then I still get just my 200 and my proper object. And if I do something, let's say here, a post method like this, I get now a uniform error body with method not allowed. And if I would do it differently, if I use this route here without a body, that's not, it's now get, but for a post route, I get this method not allowed. And if I use something which is just not possible at all, then I get not found 404. So indeed, the error handling covers a lot of cases just by having a centralized error handling. So maybe as a finishing word here, when is this sensible? Well, if you can handle an error situation directly, you can do it in your handler, but it can be a bit more convenient to just return some rejection and handle it centrally if multiple handlers basically have to return the same error. Then you just create such an object with the error, and you can easily hand out a rejection here and handle it centrally. Whatever you want is your choice. A very important issue is that sometimes our handlers need central data. That's a difficult one because we are using the asynchronous Tokyo runtime. We never know in which thread something is executed. So therefore we have to be a bit careful here. We want now to link the two routes, that we have a memory database of people such that the get route only returns people which are already in the database, and the post route can add new people. For this, we need to somehow have access to the central database in memory. To this end, we define a struct person base, which is just a hash map from string to person. So that's the name, and it maps to a person object. That's what we keep in the memory. And at the beginning of main, we create such a map. Now, since we have to hand it to multiple threads and we have to do proper locking, we wrap around it a read-write lock and then an ARC, atomic reference count. So the actual type of this database is arg rvlog person base. Why is that? Because of the ARC, we can actually send it to a different thread and we can clone it and have multiple references to it. Because of the read-write lock, we can handle access and do proper locking. And then we have the actual person base. Now the question is now, how do we hand this central data structure into various handlers? The secret sauce here is, again, a filter. So I wrote a new function which is a filter, which is called with person base. So what do? I clone this ARC and hand it into with person base. So now let's see what with person base does. With person base gets one of these RW log person bases, and it returns a filter. Now, forget about the details here. It produces a filter function. How do we do this? We do use warp any that produces a filter which maps to everything, and we attach a handler for this filter, which takes again a clone of this ARC here, which is moved into the closure here, that is, it is moved into the filter. And with this function here, we make it so that future filters which have gone through this filter add this clone of the ARC. And since the filter type here has as extract subtype or extract type template, it has this here. We know that subsequent filters will get, or handlers will get this thing as an argument. So how does this work? Due to the fact that I have put in here, for example, for my get route, due to the fact that I've used this with person base here, I know that this get handler here now gets an additional argument. It gets a string argument because of this here. and it gets an ARC read-write log person base argument because of this here. So let's look at the get handler. First argument, a string. Second argument, my atomic reference counting. Smart pointer. That means suddenly I have now access to the database, to the central database in my handler. This was only possible due to the atomic reference count smart pointer, because that can be cloned and can be handed to multiple threads. And it manages the lifetime of the object. Now, what I have to do here is if I want to look up a person in the database, I have to read log the read-write log. This gives me a guard, which is a mutex guard for the read-write log. And then I can access the map. So I can say guard.map as if it were a person base, and can look up the person in the database. If I find it, I can return the JSON of it. If not, I can produce an error which says no person with name in database. Likewise, in the post handler, we do exactly the same. We have now the body and the atomic reference counter. We can do our thing. We pass the body. Then we get a write log on the guard or on the database or the ARC. And therefore, we can now look up the name here. If it's not in the database, we can insert it because we have now write access and can return the body again. If there is already something in the database, we produce an error that the person with this name is already in the database. And we directly handle the errors here. Other than that, the code is unchanged. I know this is a lot of stuff, but let's see it in action. Suddenly, I can now here do a curl request, which first adds a person. Method not allowed, yeah, that's because I used the wrong path. That was one of my error examples. If I use this path here, I have put something in the database, and I can now do a get request with name max, and I can get the name with the correct age out of it. If I use here a different name, I get no person with max in the database. If I try to add the name max again, I get person with name max is already in the database. So it works. Let me now show you how to add authentication to such a service. For this, we need to access the headers. Look at this line here. After, in the get method, I have added warp filters header optional string with the header name authorization with non-capital letters. This adds a header lookup of the HTTP request to the route, which gives an additional argument, which is an option on a string. If the header is not set, it's none. If the header is set, it's the string value of the header. I've added this to the get and to the post method. Now let's look how we have to change the handler. The handler now gets not only the name in the path parameter, but also the authentication string from the authorization header, and again, the centralized database. And all I have to do is I call an authorize function in the beginning. Note this question mark here. The authorize function, let's look at this first. We hand in a reference to the auth variable. That is, we have a reference to an option string, and we return either an empty result or a rejection. Now, this question mark here leads to the fact that if we handle a rejection, it's automatically returned outside of the handler. So we don't have to do any kind of passing around of stuff. If not, we return a good result, but with nothing in it, and we can proceed. That's exactly what we need for the authorized here. So we match on the auth. If it is nothing, we produce an error. Again, a custom rejection with a new type of object, unauthorized, which we will look at in a second. And if there is a header, then this here is a string reference actually. Then we do whatever kind of authentication we want to do. In this case, if it is XXX, I call it not authenticated. If it's anything else, I pass it just through and return a good object here. So, Obviously, you can put other things here like JW2T token authentication or basic authentication, whatever you see fit with your authorization header. Let's quickly talk about this unauthorized. That's a very simple object just containing an error string. So we have to add it here. We have to implement the reject trait to mark it possible to be used in a rejection. And then in the end, we have to add in our centralized error handling function the case of an object of type unauthorized as a rejection, in which case we give status code unauthorized and hand out the error message from the object E of type unauthorized reference. That's all we had to do. Essentially, we now have to write this one function, have one line for every route when we want to have it authenticated. And we have to put in every handler in the beginning this authorize line. Let's see this in action. So if I do my normal person post, then I get missing authentication header 401. That's the case that no header was given. If I had add a header, authorization, and I give XYZ, then it's totally fine. Whereas if I give XXX, it says bad header unauthorized. So it works exactly as intended, and I could do the same thing for the get route. The last thing I want to show you in this video is a clean shutdown handler. We want that somebody can call an authenticated route to shut down the service cleanly. That's more difficult than you would think. What we use for this is the Tokyo Sync one-shot channel. That's a channel which can exactly take one message. We'll see how we use this. Down in the main function, we first create here the receiving and sending end of a one-shot channel. We don't have to send any data. The fact that we send a message just means please shut down. So if I do this here, I get here a transmitter, TX, and receiver, sender and receiver. These are the two ends of the channel. You can, once in the lifetime of this thing, you can send something and then you can receive it on the other side. To be able to hand this into a route, we do the old trick. We use an arc and a mutex and wrap it around this here. And notice that we wrap it around an optional here. We will see the significance of this in a second. So the type of this TX arc is arc of mutex, of option, of sender, of nothing. That's what we need here. Now we do our shutdown handler. It's path API shutdown. It's the delete type of request. We look at the authentication because not everybody should be able to shut down. And then we use this trick with the filter, which moves the TX arc clone in there with a move here, such that we have as an argument this transmitter for the shutdown handler. And then we call the shutdown handler. Down here, we start the server in a slightly different way. So we start the server not with bind, but with bind with graceful shutdown. Here we give the network address to bind, and then we give an async block like this here, which gets the receiver side and simply just awaits the channel and calls OK on it. Right. So this essentially just tells the warp server that it should wait for this receiver to happen and then shut down. And then we can just use the Tokyo task spawn to spawn it and get the join handle, which we can await here in the main thread. Let's now look what the shutdown handler does. That's again a little bit subtle. Remember that we handed in an arc of a mutex of an option of a sender. Now, we authorize as usual. And then we have to play a little bit of magic. First of all, we lock the mutex. We just assume that this works. And what we get here is a mutable mutex guard with an option for a sender in there. So let me explain why we do this option. The problem is that the shutdown handler could be called multiple times. But we are only allowed to call send on this one-shot thing once. So therefore we do the following trick. Once we have the mutex acquired, we have access to this option sender. In the beginning, it will be a sum of the sender. And the moment we first use it, with the first time the shutdown handler is called, we use take here. Now, since tx is a mutex guard with option sender in here, we can try to take out the wrapped sender from the option object with this take here. So this here is now is again an option sender. Either we got it out if we are the first ones acquiring the mutex and trying to transmit something. Then we take it out. At the same time, we transfer the one stored in the arc mutex here to be a none. Once we get it, we can actually send and lead to the shutdown. Whereas if we don't get it, every further time, we now would get a none out here that if wouldn't match and we no longer send. So that's the trick we work around the fact that we can only use it once. And whatever we get then, we just hand out I just used an empty error message here with an error code of 0 and status code OK. That is the shutdown handler actually responds. So let us see this in action. The service runs. I can send something as before. Hang on. It's only running now, so that's all fine. And the moment I do an delete request to API shutdown, I get missing authentication header, fine. Authorization XYZ. I get error code 0, error message empty, and the service has terminated. I know, this video is long. It's much longer than my 10-minute upper limit. However, I wanted to finish this, and I wanted to show you in 218 lines a complete server which uses HTTP 1 or HTTP 2. It can handle multiple request routes, get and post. It has a centralized database. It has authentication. It has clean shutdown. It has different handlers. It's fully asynchronous, and it uses one of the world's best and probably bug-freest implementations of the HTTP protocol by using Tokyo and Hyper behind the scenes and Warp, of course, and Request. So it's extremely efficient. It uses completely asynchronous code. It has central error handling, authentication. If you want, you can easily run it over TLS. And it's just such a fantastic thing. And this is all in 218 lines. And I hope that with this and the previous video, you can actually start coding HTTP servers and enjoy this immensely powerful system yourself. As I said, this is a tough one. You will probably watch this video multiple times, but you can also just look at the final outcome and copy paste what you need. I hope you enjoyed this video, and I'll see you in the next one.